All right, hello. Thanks everyone for coming. It's nice to see some familiar faces and a whole bunch of new faces here at the SIG-Multicluster Intro and Deep Dive. I'm Jeremy. I'm one of the co-chairs of SIG-Multicluster. I work on GK at Google.
I'm Stephen. I'm the other co-chair, and I work on OpenShift networking at Red Hat.
I'm Pavanipriya Sajja. I'm a UX designer working on multi-cluster project.
So yeah, thanks everyone for making the trek down here. It is quite a long way from the showcase. So we're going to cover a few things today. We'll start with the usual overview of the SIG and what we do, what we focus on. We'll go over the projects. This time we've got some new information. We're going to share some findings from a user experience survey and kind of understanding of the multi-cluster audience. So hopefully, any users here will learn that you're not alone, and any project maintainers will kind of learn what to focus on and what really matters to the Kubernetes community. And then we'll talk about how you can contribute. So first, what do we do? So the most important part of this SIG is to focus on basically making it easier to work with multiple clusters. We've seen, more and more over the last several years, multi-cluster is everywhere now. Everybody has multiple clusters for, a variety of reasons. Could be environments, it could be, capacity chasing, it could be geo constraints. And deploying those applications can be challenging. It can be incredibly powerful. It can boost your reliability, it can boost your performance. There are lots of reasons to deploy applications across multiple clusters, but actually orchestrating them is hard because, as anyone who's been around Kubernetes for a while knows, basically all of the core concepts in Kubernetes evolved with the idea that the cluster is the center of the universe and anything outside is other and, completely external and has nothing to do with Kubernetes. And when you're running a multi-cluster environment, that just is not the case. We made a lot of progress over the last few years, but there's still new problems to solve. How we solve this is important as well. So step one, we always try to recognize the diversity in the ecosystem, and this comes in a variety of ways. The most obvious one is, where are your clusters? Are they in a public cloud? Are they on-prem in a private cloud? Are they edge? Is it a mixture of all of these? Environmental constraints. This could be, what compute you have in your environment, how much, what kind. It could be, where is it geographically. It could even be political constraints and kind of understanding what drives each user, each project to solve different problems in different ways. That it's really hard to come up with one-size-fits-all solutions. We also want to recognize that a lot of solutions exist, and this is the existing ecosystem. Out of necessity or trying to solve specific niche use cases, a lot of problems have been solved before we even get to them. And so it's really important to us that when we come in and we try to figure out how to solve a problem and create a standard or elevate an existing standard, we do so in a way that's compatible with what's already out there. We can't come in and just say, this is how it's done, and run over projects that have users and have success. But we still want to kind of help create the consistent experience that's important, so that both users can have trust that wherever they're running, they're going to have a consistent environment and familiar APIs, familiar process, but also maintainers building projects can trust that their dependencies will work, and they can plug and play what as needed depending on the environment and other constraints. So that consistency with existing API or that with existing products is important. We also care about consistency with existing APIs. So if you've been in Kubernetes running single cluster for a long time and you're branching out into multiple clusters, we don't want it to feel like an entirely new world. So where possible, we try to make the multi-cluster versions of concepts match their single cluster versions. And when we create new APIs, we still want to make sure that this multi-cluster world feels like Kubernetes. And lastly, composable building blocks are really important, because we're not going to solve the solution, or we're not going to solve the problems with the perfect solution for everybody. And you're going to want to be able to pull things out and replace components as needed. You're going to want to take some things we've built and not everything. So we want to provide a bunch of building blocks that you can assemble in a way that works for your needs, and supplement with your own tools wherever your work takes you.
So as a SIG, we host a number of projects. And to help understand how they all fit together, this is a diagram of what's known as a cluster set, so a set of clusters that work together. The top one, the yellow one, is the hub cluster, and the blue ones are worker clusters. So this is a hub and spoke model. It's not the only model of multi-cluster, but it's one that helps to understand where all the projects fit and what their role is. So the first project, and these aren't in order of importance or chronological order either, it's just a presentation order. So the first one is Cluster Profile API. And this is an API that can be used by external consumers to find out what's in the cluster set. And so there typically be a multi-cluster controller that knows about all the clusters, and it stores information about all of them in cluster profile. And the recent addition to this is the ability to store credentials in cluster profile. And so that means that an external consumer or or an internal consumer, if necessary, that has access to the hub cluster and the appropriate permissions can find out how to connect to all the other clusters. The next API we have is the About API, and this is similar to the Cluster Profile API, except that instead of being in the hub cluster, it's in all the member clusters. So each member cluster can store information about itself, publish information about itself locally in the About API. And this is stuff like, for example, the cluster ID. So in a single cluster world that Kubernetes was designed for, the cluster is the universe, as Jeremy said. And so when you're talking about the universe, you don't give the universe an identifier. It just is. And so the same goes for clusters. Clusters don't usually have identifiers. So, in practice, they do in your kube config, for example, but not in the cluster itself. But About API allows you to have a store an identifier that can be used to match things up in the cluster profile, for example. The next one is the Work API, and this allows work to be pushed to member clusters. So for example, here, the green workload was pushed to the left-hand cluster, and the yellow workload was pushed to the right-hand cluster. Related to that, we have a KEP that's in progress for a new API, which is the Placement Decision API. And this is used to store, a placement decision, which is basically a description of where a workload should go or went. And this is an interesting API because it illustrates the principle that Jeremy talked about, where we want to standardize things that are useful in practice. And this is an API coming from a number of multi-cluster projects and that we're standardizing in the SIG. And next we have the Multi-Cluster Services API, MCS API, and so this allows services to be used from one cluster, published from one cluster and used in another. So for example, here, assuming the green workload on the left-hand side was actually a service, it can be made available on the right-hand side. And then last but not least, but slightly different, is multi-cluster runtime. So this isn't an API, it's a library, and this is a bit of a new development for the SIG. So we used to host code projects, KubeFed, things like that, but for a while we've only hosted APIs. But now we've added multi-cluster runtime, and so this is an extension to the controller runtime, which you might be familiar with, that allows you to write programs that work in the same way as with the controller runtime, so with a reconciliation loop, for example, but across multiple clusters. And it can use, for example, the Cluster Profile API to get all the credentials to go and talk to your different clusters. And this is actually proving to be really useful, and it's gaining quite a lot of traction. So these are all the projects that we have. And so now we can go into the user experience survey findings.
Good evening, everyone. Today, I am excited to walk you through our user research survey report on multi-cluster operations. Our goal is to make complex systems easy to use and difficult operations turns into human-friendly for engineers. So we designed survey for engineers who work with multi-clusters. We focused problem areas on tooling, environment, troubleshooting, observability, and collaboration. In our survey, we included qualitative and quantitative questions to learn about how engineers are work what they use, and why they are making certain choices. We sent this survey to Kubernetes SIG community channels, and we did receive responses from 150 engineers. To analyze the research data, we used text analyzer for written responses and Python for numerical data, which help us on identifying the patterns between demographics tools and challenges. Our respondents represent diverse backgrounds, such as 38% are platform engineers, 26% are DevOps engineers, 10% are SRE engineers, and the remaining are software developers and cloud engineers. This shows that our survey reached to different people. Now, let's look at the key findings. We ask engineers one key question: why does your organizations run multi-clusters? And we discovered 5 common patterns. The first common pattern is infrastructure provider. Engineers deploy clusters across cloud, on-premises, and edge locations. This gives them flexibility and helps avoid vendor lock-in. Second, isolation. Team keeps workload and environment separate for better security and easier management. Third, business unit. Each team gets their own cluster, which gives them ownership and making compliance easier. Fourth, region. Engineers deploy their clusters across different geographical locations for a better performance and redundancy. If one region fails, others keep the system running. And the fifth, most common pattern is environment separation. Organizations separate development, staging, and production environment. This lets engineers test the deployment without breaking the live systems. Now, let's move on to our next slide, which represent key challenges engineers face in multi-cluster operations. Our user research identified 4 major challenge areas. 51% of engineers are struggling with workload management, 39% with observability, 25% with operational complexity, and 10% with time management. Engineers struggle daily with cluster management, such as stateful workloads, upgrades, configurations, resource distribution, and multi-cluster complexity. Engineers struggle to understand what's happening across the cluster is very challenging because the data spread across the multiple tools. On the other hand, they are complaining about network complexity. During the critical alert, engineers follow the structured on-call process, but our research identifies that every alert feels unique to them. However, the alert looks might familiar, but the cause and impact is always different. The real bottleneck is about situational awareness. If they know which cluster, what service, and how the impact, then they can act with confidently. Engineers reported challenges with context switching, repetitive tasks, environment setup, missing zero trust templates, limited team knowledge, and failover scenarios that requires manual interventions. Engineers lost countless of hours on repeated setups, slow deployments, and troubleshooting. These are the key challenges that we can clearly say that engineers having difficulties on working with multi-clusters. We ask engineers that what do you want in their future of multi-clusters? 3 common patterns identified from the user research: AI and automation that can take over the daily task so the engineer can focus on high priority tasks. Flexible architecture that adapts the different deployments, performance, and cost needs. A simplified UX with easy to use dashboards, clean documentation, and simplified workflows that designed for every engineer. So from new to experienced engineer work with confidently. User research also revealed the two uncommon patterns, such as dashboard as a code for a functionality and specialized hardware requirements for multi-cluster operations. Now, let's move on to our quantitative highlights. Our first pie chart shows that half of the engineers are managed 1 to 10 clusters per month. 1/3 of the engineers are managing 11 to 50 clusters per month. And over 1 in 5 engineers are handling more than 50 clusters per month. Now, next move on to our second pie chart, which represents single cloud deployments are most common. However, we combined alternative approaches, which make slightly more than half. Let's move on to another slide and third pie chart, which represents engineers strongly prefers multi-tenant models over single-tenant models. Additionally, 1/3 use a flexible hybrid approach. Interestingly, 1% of engineers mentioned that they don't want to say or not to prefer anything. Our final pie chart, which represents that most engineers prefer automated failover that triggers immediately. Nearly a quarter choose to evaluate the situation and respond manually. The remaining engineers want smarter automation, such as auto-scaling based on health metrics or policy-driven workload redistribution. Now, let's move on to our final quantitative analysis. The graph represents that engineers are using different tools to operate their range of multi-clusters. From the graph, we can say that Argo CD and Rancher are heavy used in smaller deployments and decline significantly as cluster count grows. Next, custom controllers and Flux CD represent that consistent usage across deployment sizes or increasing with scale. Caverno and Thinas mentioned that peak usage observed in 11 to 50 cluster environment. Istio and Cilium cluster represent that limited but steady usage across all deployment scale. And from the graph, interestingly, we identified that there is no engineers are not using any tool to operate the multi-clusters. One of the platform engineer who manages more than 50 plus clusters says that multi-cluster isn't just a scaling up choice, it's a strategic evolution towards flexibility, resilience, and innovation. From the data analysis, we discovered 5 user research areas, such as documentation gap, centralized monitoring, AI-driven automation, operational complexity, and developer UX. Now, let's see how our recommendations can improve these user research areas. Review multi-cluster project materials to identify what's missing or outdated and create a practical guide with real examples. And work with SIG community to build a tested documentation for engineers' daily work. We recommend identify the current tools, overlaps, and gaps, and create a centralized observability system with common standards of logs, metrics, data storage, network visibility, AI-connected alerts, and role-based dashboards. We recommend build the automation and AI-driven system that can take over the engineer's routine task. We recommend organizations can provide a hands-on training in multi-cluster operations to the engineers and improve the zero trust templates and make automation more reliable. Knowledge sharing through playbooks and peer learning can close the skill gaps. Our final one is the developer UX. We recommend study the developer's existing tools, practices, and method, and identify what's slowing them down, and use these study insights to build a developer-friendly solution on multi-cluster operations. One of the software developers said, "Make it easy." Our user research completely highlights that the future of multi-cluster management is the combination of technical excellence and human-centered design. Please scan the QR code and please share your multi-cluster challenges with us for a deeper study.
So I'm going to talk a bit about how you can get involved, and this is the best way right now, I think, if you want to get started, is to give us feedback. As Priya mentioned, we started with 150 engineers answering the survey from the community, and that's great. And if you're been a long-time member, we love you, we appreciate you. But if you're new, we want your input because you're probably being overlooked, and we love to grow this. Give us the feedback, answer the survey, help us figure out where we should be focusing as a SIG. And we'll have the link later as well, and we'll send it out, so you can always join the list that Stephen's going to talk about in a minute. So if you want to be part of the SIG, it's really easy. You can show up, you can email the forum, and just tell us what you're working on. Tell us the APIs you're building or that you wish were built. What are the concepts that are missing? Also, we meet weekly or twice weekly, and we're always open for demos. If you just want to show off your work or your problems, we are here. We would love to hear them. Also, if you have any unique needs, anything that you think is kind of unique and not showing up in these lists, if that research resonated with you, come tell us how much it resonated, which parts. If it didn't, tell us why you're different. I think that's really important and helpful for us, figuring out what to work on. And we have a lot of ways that you can contribute if you want to actually get involved hands-on in the SIG. You can contribute tests to our various projects. You can help us fill out our website, which is a little bit lacking. You can help us build more research like this and fill out the survey. What questions are we not asking you that we should have been asking you? Give us feedback on the KEPs. We have a few in flight right now that are the projects that we're developing. If anything's not resonating, go on GitHub, comment, give us the feedback, come to meetings, or propose your own KEPs. And I think most importantly, try our projects. Install them, see what works, see what doesn't, give that feedback. We are receptive and happy to make changes.
All right, so we have a website where you can find out more, and as Jeremy said, it's lacking in information on the contents of most of the projects, but there is a very detailed how to get involved page, which has links to the mailing list and has a calendar with our different meetings, and links to our Slack channel, which you can see up there as well. And if you sign up to the mailing list, as usual in the Kubernetes world, you will get calendar invitations to the calls, which take place every week on Tuesdays at 12:30 Eastern. And we also have a bi-weekly APAC call on Thursdays. So the next one is Thursday next week. And that is currently scheduled at 6:30 a.m. UTC, but that's a little bit early. So we're moving it back to 7 a.m. And thank you for being here. Like Jeremy said, this late hour in the day. That's the QR code for feedback. I'll leave it up for a little while, but you'll find it on the schedule website anyway. I'll upload the slides too, and maybe we'll move back to the survey QR code. And we have a few minutes for questions.
And if you do have questions, there's a mic on a stand in the middle of the aisle there, so please head up there. And we'll also hang around for a little bit afterwards if anyone wants to come up.
Hi, everyone. I would like to say thank you to Laura, she's not here, Nick, Quarantine, Jeremy, Stephen, Josh Burkus made this research happen. Thank you so much. And multi-cluster team as well. Thank you.
All right, I can try again. All right, I guess that works.
Success.
Yeah, thanks for the talk. I was just curious, could you guys do a quick speed run of where these APIs are being used in commercial products? Like, I'm pretty sure it's being used in OpenShift, for example, but who else is making use of some of the APIs, the multi-cluster APIs?
Of which API, sorry?
You spoke about like the various API sets.
All right, all of them.
SIG Multicluster. Yeah.
So I don't think there's any single product that actually uses all of them, or project that varies. So, well, MCS API is probably the most commonly supported one. Cluster Profile is growing, About API and Work API as well. But that's one of the issues really with all these APIs. We add APIs that try to standardize things that are upcoming or may already exist, and so then the projects actually need to adopt them before they can be widely useful.
Right, and so like MCS, like GKE has support for MCS. We have
ACM, OCM.
Yeah, we have Istio. AWS has one as well. Like there's quite a few implementations out there. Some of the newer projects are still in co-development with various projects, so they will be implemented, but maybe not yet. Yeah, MCS is definitely the most mature, and it's also got gateway integration as well, so you can target a gateway at it. We worked with the gateway API team on that, but some of these other APIs are much newer as well.
Sorry if I missed this in your talk already. I had to come and go a bit. But most of the talks that I've been to that have to do with AI over the week have mentioned multi-cluster, as needing to change to serve the needs of AI, just like everything else that we do needs to change to serve the needs of AI. Is there anything that you guys are working on now or have already worked on that I missed in the talk, sorry, regarding AI?
We did not call out AI, but the reality is that, yes, it's definitely driving a change in need. I think capacity scarcity, trying to find those accelerators is a big driver for multi-cluster, and it's leading from, before I would say like with, MCS, we were focusing on stitching clusters together. A lot of the more recent focus on
Cluster Profile in particular.
Right, like scheduling is really about, how do I find which cluster might have the chips that I need, and then does it have them now, right? So I think it's driving a focus for sure. Like everything else in the industry, we are not untouched.
Yeah.
Yeah.
But what we're seeing perhaps in practice is that AI is it's not necessarily creating new feature requirements for us. It's focusing on perhaps things that are, helping us focus on things that are useful, and also providing interest and investment in areas that are more generally applicable but weren't of interest beforehand, or not enough.
Right. Like I'd say the AI is driving core Kubernetes changes, and then we need to make them work, right? And so that's the part where all of the changes that are happening in Kubernetes, supporting new types of workloads like leader worker set and job set and things like that are evolving out of the needs of AI, are things that we need to support with these APIs. So some of this is kind of inherited from the core project.
Thanks for the talk. Can you share a bit more about the maturity of the APIs, in particular the multi-cluster service APIs, and the kind of outlook for the future? We were kind of considering using them in our project, but it wasn't completely clear to us, to be honest, how much stable that would be going forward if we are, for example, creating the resources directly from our tooling and not kind of semi-manually and so on.
So we have embarrassingly let multi-cluster services as the API stay in a non-GA state for far too long, and we are working on that. But there are GA implementations of it, and they are completely safe to use. And so what we've seen is it is a pretty stable API. We tend to be adding things gradually as they show up in like services, like things like dual stack, things like that. But the core API hasn't changed in a long time, and the implementations we have in the community are stable. So it's it's pretty safe to use.
Thanks.
So we're trying to looking for like the solutions for multi-cluster using the OCM on our end. So one of the biggest problems to adopt this API is now we have in multi-cluster world, we are using the hub spoke model, and then the customers want to access the cluster and their workloads as they used to do for the single clusters. So I'm curious about like the multi-cluster SIG also will try to find a way, kind of the tooling side, actually, how we can provide the same experience that we used to provide in the single cluster.
Yeah, so we had a chat about that at the meet and greet, and that's definitely something that we haven't really paid much attention to as a SIG. We've been focusing mostly on the APIs, but as indicated in the survey, it is important, I think, to look at the management side of things, and that's something that we'll definitely think about. And if you want to get involved, or not necessarily have to, pitching in, actually doing the work, but even just giving ideas, do please come along to the meetings if you can.
Okay.
Yeah, please join and kind of just tell us what you wish we had.
Sure. Yeah.
Yeah. Well,
or even better, much better, actually. All right.
Yeah. Well, thank you very much.
Everyone.